We also introduced in polynomials another, we called it a function operation. It's not one of the basic operations like add, subtract, multiply, and divide. It's just a combination of functions, and that was called the composition. Did we use the notation with the circle or the parentheses? Remember? Okay, so the way that you're going to see it both ways. Now I think the book uses this open dot that looks like an O sort of. We saw it like this in chapter 4, right? Okay. You can write it both ways in your notes today. Okay, so one thing I want to make note of in the notations, if you have something like for adding f plus g of x, that is just function notation. It does not mean multiply by x. So I often get a lot of students who just don't practice enough with their notation, the way mathematicians are going to write things, and they think that they should add an x to everything that they do, like multiply through an x. That is not the case. That's just the x as in f of x, g of x, whatever letter we're using to say it's a function of x. But it doesn't mean multiply by x. So we want to make sure we're careful and we're paying attention to notations on our homework so we don't do those same types of things when we get to quizzes and tests. Add, subtract, multiply, divide, those are pretty obvious, right? How you're going to go about solving them. I'm going to put 1 star next to divide. So we're going to be doing the function operations, and we're also going to be talking about domains. Well, back in chapter 4, we talked about domains. If you're division and you've got an x in your denominator, you are not allowed to divide by one number. I can divide by 8. I'm not allowed. I've never divided by one number before in my life. 0. Okay. So let's say restriction to the denominator, or restriction to the domain, sorry. X cannot make the denominator equal 0. So depending on what your denominator is, you might have to look, is there a way for that function that's in the denominator to equal 0? If so, I have to restrict my domain and say x cannot be this number, because this number makes my denominator equal 0, and then I can't divide. It's undefined. Okay, so then it wouldn't be a function. Previously, in polynomials, that was our only restriction to the domain, was dividing by 0. We couldn't do it. Now that we've progressed through chapter 5, we know about other restrictions to our domains. What other types of restrictions to your domains might you encounter? What do you mean by negative? Imaginary numbers. When do you get imaginary numbers? When you do square root of negatives? Even roots of negatives? Okay, so I'm going to put at the bottom of this note if you have an even root in your function, you may have a restriction to your domain. So before we only worried about domain if it were division. That was the only time we ever questioned domain. Now we question domain if we're working with some kind of radical function that has an even root. I think Mason was mentioning fraction exponents. If I have a fraction exponent that has an even denominator, that would represent its root. And I would also consider that I can only put in 0 or positive x's into those types of functions. Okay. Second semester, we're going to talk about another family of functions called exponentials and logarithmic functions. And you'll be introduced to now a third restriction to your domain. Besides dividing by 0, besides square rooting or even rooting negative numbers, logarithms are going to offer you another restriction to your domain. Okay, we're going to talk about the compositions as we go through our examples, and you have to be real careful with compositions when you state your domains. Okay, so for the rest of our notes, I'm just going to pick these 4 functions. So if you write these 4 functions in your notes, f of x, g of x, h of x, and j of x, we're just going to keep reusing the same functions. That's kind of what your homework is like. Like I give you 5 functions, I just give you a whole bunch of different function operations. So we'll do some different function operations, and then we'll talk about domains. And if you have a question, make sure that you ask that question, especially about domains, why we're going to say what we're going to say. So we have f of x equals 2x minus 3. G of x equals 3x to the 1/2. H of x equals x squared plus 4. And j of x equals 9x to the 1/3. Okay, we're going to perform the function operations and then talk about our domains. So my first set of function operations is f minus g of x.
What's a domain? Is that
All
the
the
same like when we're graphing?
Yes, domains are the x values that you can put into a function and still get outputs. So like you can't put in an x that would make your denominator equal 0 because then you have no output, it's undefined. You can't put in an x that would make the radicand of an even root negative because then it would be imaginary. So the domain is your x's or your inputs that allow you to get outputs. We'll do these in a minute. Let's just do f minus g of x. So f minus g of x, we're going to do 2x minus 3 minus g of x is 3x to the 1/2. Anything you can do to simplify? Rearrange, maybe, but nothing is a like term, right? So you can leave it as such. If you want to rearrange it, like maybe have all your x terms first. I could write it like this, but then I'm done. Okay. For the domain, what x's can I put in to my new function and get answers back out? greater than or equal to 0. Why did you restrict your domain?
Because
You have an even root right here. This is 3x to the 1/2. You could rewrite this right as 3 times square root x. And can you put any x that you want and still get an answer back out in your new function? No. If I put in -4, sure I can do 2 times -4. I'll get -8 for the first term. But if I try to do -3 times -4 to the 1/2, that's going to be imaginary. And that's not going to give me an answer. So we would say domain is x is greater than or equal to 0. Okay. Let's do f of g of x. So this is read the same way as this. It's a composition. I don't care which way you write it, just be able to recognize either one. And remember with compositions, they are not actual like add, subtract, multiply, divide. They're substitution. So this is asking us, take g of x, which g of x is this 3x to the 1/2, and substitute it in for x in f of x, the outside function. So f of x was what? 2x minus 3. So we're going to say 2 times 3x to the 1/2 minus 3. You can multiply to simplify, and you should. If you can simplify it all, you should do the little simplifying pieces. So 2 times 3 is 6. And I'll get 6x to the 1/2 minus 3. That's my new function. What are the x's that I can put into that function and get answers back out? Same thing. X's that are greater than or equal to 0. Anytime we encounter this x to the 1/2, we're going to have that whole issue of can't put negatives in.
So if it's an odd root, it'd be less than 0.
Oh, if it was an odd root, what would my domain have been?
Less than 0.
All real numbers. I can do odd roots, cube roots of positive numbers, like cube root of 8 is 2. I can do odd roots of 0, cube root of 0 is 0, and I can do odd roots of negative numbers. Cube root of -8 is -2. So all real numbers. Okay, that's related to the graph of the cube root function, right? It goes on in both directions forever. Okay, let's try h divided by f of x. I've scrolled down on my screen, so you guys will have to help me out. What is h?
X squared plus 4.
X squared plus 4. And we're dividing by f, which is 2x minus 3. Now be careful on these division problems. We talked about this back in chapter 4. In order for you to be able to do any kind of canceling, they have to be factors that are the same. 2x minus 3 doesn't factor at all. X squared plus 4, can you factor that? No, it's not a difference of perfect squares. This is unfactorable. So these things don't share any common factors, therefore you cannot simplify anything. You can't cross out an x. That's not a factor. That's part of a term. So this is done. And then if we're talking about domain, what would be our domain for our function? What would be the trouble spot in this function? If the denominator were equal to 0. So 2x minus 3 equals 0. What number makes that equal 0? 3 halves. But don't you agree, like, the denominator could be positive or the denominator could be negative and I could divide, right? It just can't be 0. And the only thing that's going to make it 0 is if I put 3 halves in. Because then 2 times 3 halves is 3 and 3 minus 3 is 0, and that's no good no matter what the numerator is. So I'm just going to say x's cannot equal 3 halves. So we did that back in chapter 4. If it's division, you're just excluding the thing that makes the denominator equal 0. Now there could be more than one thing, but you would exclude that. Yeah.
Would you also be able to put that, just make like the greater than and less than and just double the equal sign? Like 3 halves is greater than that.
No.
Okay.
I can imagine possibly what is happening in your mind. I mean, when x is not equal to 3 halves, it's saying x is greater than 3 halves or x is less than 3 halves. However, this is not a thing, or I can't even do it. I can't.
Okay.
No, that's not a thing. So in an or case, you can't put them together in one. Because it's like, it couldn't be greater than 3 halves and less than 3 halves at the same time. So you can't write it as one whole thing. Okay, let's look at f divided by h. That's just flipping it, right? So this would be pretty easy for us. 2x minus 3 over x squared plus 4. Okay, what do you say about your domain now? Yeah, nothing, that's a great way to think about it. Nothing squared will equal -4, which would get you 0, right? Anything squared is going to equal what kind of number? A positive or 0. So if you're adding 4 to that, that's always going to be positive. So we would say x could be all real numbers in this case. So yeah, you're just kind of running through your mind. Did I encounter any square roots? Fourth roots? Sixth roots, even roots, right? Because those have restrictions to domain. Or did I encounter any division? Because I might not be able to divide by 0. But not all division problems have a restriction. Okay, next up. Same 4 problems. Okay. What is this one asking me to do, this first one? Multiply. G times J. So I'm going to do, what is that? 3x to the 1/2 times 9x to the 1/3. And remember, I'm never adding in an extra x for this x over here. This is just function notation, so I really just ignore it. It doesn't mean anything. How can I multiply those? When I change them to radicals, one would be a square root and one would be a cube root. Can I multiply if they don't have the same index?
That's what.
Yeah, what should you do with your exponents if you have the same base? And you're multiplying. Add your exponents. And in order to be able to add 1/2 and 1/3, they have to be common denominators. Yeah. You can also multiply 3 times 9 is 27. This is going to be 3 6 and 2 6. So when I add them, I'll get 5 6. Domain? X is greater than or equal to 0. What was our giveaway for greater than or equal to 0? Even root. If we're dividing by 6 in the denominator of a fraction exponent, that's the 6th root. So we gotta divide, or sorry, gotta restrict our domain. Okay, what about G plus J? What does that look like? 3x to the 1/2 plus 9x to the 1/3? What has to be true in order to be able to add or subtract in mathematics?
They have to be raised to the
They have
same
to be
thing.
like terms. Are they like terms?
Uh-uh.
No. Okay, we're done.
Yeah.
Right? Don't like force something that can't happen. Like not all of them require some extra simplifying, but you should always look and check. But you can't add an x to the 1/2 with an x to the 1/3, just like you can't add an x squared and an x cubed. They're not the same thing.
So you can't do what you would do with multiplication, where you would change, where you would find common denominator exponents. You couldn't do that in
No. Nope. Okay. I have stressed numerous times, adding and subtracting in math, no matter what math class, chapter, section, teacher, whatever, you are required to have like terms. Those are not like terms, and they never will be. Right? So we don't add them. We just leave them alone. What would be your domain? Yeah, x is greater than or equal to 0. For the 9x to the 1/3, that has a domain of all real numbers, but we still have to be able to plug it into the other one to get an output. So it has to be greater than or equal to 0. Okay. G of j of x. It's hard for me to say G and J. Which one was G? 3x to the 1/2? Okay, so that's my outside function. So I'm going to start with 3. And then where the x is, I'm going to put in
9x
J-
to
J-
the
the j function, right? That's the inside function. So I'm plugging 9x to the 1/3.
and then 1/2 outside.
And then raise it to the 1/2.
And then multiply this.
What do you mean multiply?
The 1/3 and 1/2.
Oh, okay, well this is going to be x to the 1/6.
27x. No, distribute.
Okay, so what is this, in addition to like multiplying, what does this exponent of 1/2 mean? It's a
Square root.
square root. So aren't you square rooting 9x to the 1/3? And what's the square root of 9? 3. Some people were saying like distribute it to both parts. You don't distribute exponents over plus or minus, but you do distribute exponents over multiplication and division. That's a property of exponents, right? Okay. So this is really 3 times 3x to the 1/6, so we should have a 9. Domain? X is greater than or equal to 0. If you're in the right mindset, domains aren't too terrible. Okay, but you just gotta like refocus your mind. So if you don't finish your homework and you gotta do some of it at night, you gotta review before you start what kinds of things restrict your domains. Okay, I think I have one more. H of g of x is h x squared plus 4. Okay, and g was the 3x to the 1/2. Is that correct? Okay, so I'm plugging 3x to the 1/2 in for the x in x squared plus 4. Substitution. So that's going to be 3x to the 1/2 squared plus 4. How do I simplify that? Okay, multiply this, so that's going to give me x to the first. Also, it is 3 squared, which is 9. Okay, this one is tricky. It looks like all real numbers, doesn't it? I agree. It looks like a linear in the end. But think about what a composition meant. If you're doing a composition of h of g, first you calculate g, you get an answer, and then you plug it in for h. Can you calculate anything you want in g? No. What's the restriction to g? greater than or equal to 0. So because you technically, in this composition, have to be plugging into the inside function first, you're going to restrict your domain, x is greater than or equal to 0. Now that's probably like the toughest domain, is when usually like it's in a composition. If you square an even root or raise raise a fourth root to the fourth, it's gonna turn out looking like it's linear, like it should be all real numbers. But you have to remember that really you have to be able to calculate, in this case, g, in order to be able to plug it in for h. So you have to limit it to the inside functions domain. That can be tricky. All right, your homework is a worksheet. You should get started. You can ask questions. You can get help from your neighbors and from me. When you're reading the directions on the front page, notice I only ask you to do domain for a few problems. If you want to do it for all, you can. Most of them are all real numbers on the worksheet. So I only ask you a few of them. We did harder problems together.